All right. We'll go ahead and get started. I'm going to go ahead and just introduce our presenter today is Nick Hernandez from Wayman Fire. His camera, I think he's having a little trouble with the camera, but his microphone is working. So he is going to present. And what we'll do is we'll let him go ahead and present. I'll keep admitting people as they're coming in. If you guys have questions, feel free to stop and ask, or we can wait to the end. It doesn't matter. So with that, go ahead, Nick, and go ahead.
Okay, thanks, Chris. I'd like to thank ABC and Alicia for setting this up. More than happy to share my experience and what I do for a living with you guys. And so I'll just jump right in, being that we got some limited time. My name is Nicholas Hernandez. I'm a sprinkler designer with Wayman Fire Protection. If you're not sure what a sprinkler designer is, don't worry about it, because I wasn't sure in high school either. I really just kind of stumbled into this through college, but I'll get to that. A quick backstory on how I got here. I graduated from Newark High School, 2007, worked part-time in retail for about 3 years, then decided to get into college. I went to Deltech Community College up here in Stanton, Delaware, and kind of went in, bounced around a bit, and did a couple things. I tried culinary. That didn't work out. I still can't cook today, so I made the right call there. I also did a little bit of computer programming, and that really wasn't really getting me interested either. So what happened was Deltech offers this free seminar where you get to take a survey and stuff and figure out like what maybe interests you and stuff like that. And I feel like a life safety thing has always been like something that has been very involved in my family and stuff. My dad was a firefighter, my brother was a firefighter, and I stumbled across this thing called fire protection engineering that Delaware Tech offered. It was kind of its own deal back then. Today it no longer exists, unfortunately, but there are still ways of getting into it through the architect field there. And you can still find other universities around that actually still offer it. But that kind of gave me a nosedive into what I do today. I did the fire protection thing and took a bunch of classes. There's a bunch of stuff you can go through there. I did the more of the drawing end, that more interests me, but there's ways you can get involved through other parts of the fire safety business. Like if you wanted to be involved in like being a fire marshal or something like that, or arson. That stuff is all pretty much bridged through the fire protection engineering. So I went through that and took the classes and all that stuff, found out that I liked the design portion of it. And in the final year of college, I wanted to get my feet wet in the actual job force. So I actually, I went into a company called Hoops Fire Prevention, and that services like fire extinguishers. They do basic inspections and things for the state, and they primarily do just fire extinguisher contracts. So what my job was is I serviced fire extinguishers and pretty much made sure every 5 years you would have to go through and they would do a 5-year internal inspection. The extinguisher would have to come back to the shop and it would have to be reserviced. So that kind of just got me into the field of fire protection. It's not related to much at all what I do now, but I just wanted to kind of jump into that. But then from there, after about probably a year after I graduated, got my associates through Deltech, I wanted to actually get more involved in what I do today, which is sprinkler design. And I took an entry-level position in Baltimore with Reliance Fire Protection. They're based out of Glen Burnie, Baltimore. And it was an entry-level position, so it was kind of perfect spot for me. And it got me comfortable with how the things work in the design world and how to do drawing and stuff. I know a lot of you are probably familiar with AutoCAD. I did a version of AutoCAD, but it was the fire protection version there. And kind of that's where I really started picking up on the drafting. Never really did drafting in high school. So I kind of was a little bit of a step back from there. But yeah, so I dedicated about a year's worth of time at Reliance Fire Protection in Baltimore. But due to scheduling conflicts and distance, I actually wanted to come closer to home because I'm up here. And I got a actual field job as an apprentice in the field for Simplex Grinnell, which is now Johnson Controls. What I mean by that is I was actually an apprentice for sprinkler fitters, field guys, the actual hands-on guys in the field. And that actually got me more comfortable with the field aspect of things. That's kind of what one of my purposes was. So I actually put in a year through an apprenticeship with Simplex Grinnell, which is now then, like I said, Johnson Controls. But then after about a year there, a year and a couple of months, I left and wanted to get back into sprinkler design because that's what I went to school for. And like I said, that was primarily just a bridgeway to getting back into a design up closer to home. That's when I came across Alicia and Wayman Fire Protection. I actually got a job with Wayman Fire Protection in 2014, and I've been here since. And since I've been here, I've gotten certifications that I've needed for the state of Delaware and nationally. One of them is called NICET. That's kind of a big deal with sprinkler designers. They have some other things they do too, but primarily for sprinkler designers. NICET is the certification that you get to be able to submit drawings and things like that to separate entities, states, jurisdictions, places all around. I mean, now that I have my NICET certification, I could submit drawings here, California, all different places of the actual nation because it's nationally recognized. So I pretty much got my certification. I got Delaware certified, which is important for Delaware. Some places, some states have their own certifications. You have to go, you have to take a state test and actually be able, in order to be able to submit drawings to fire protection reviewers, fire marshals, etc. And so I got my Delaware certification after I got my NICET. And now I pretty much work directly through Wayman with sprinkler design as like their designer. But in my field as a sprinkler designer, you can actually go and work for like a dedicated design company. You could work for an engineering firm. There's just unlimited things you can do. My job is pretty much is to pretty much work directly through Wayman projects and stuff. But if our inflow of projects were greater than what we could handle, and we couldn't put out the same amount of outflow, we would actually go to outside design companies that other designers would work for, like even people that own their own businesses, and they're usually called freelance designers. So they would actually do their own thing, and all they do is design. They don't do anything directly with the companies. We just pay them to do the design, and then we take it back from them when they are complete. But as of me, I'm just an in-house designer for Wayman Fire Protection. So to bridge over to what my tasks are, we're usually, so pretty much where I start working is I usually get my projects from my salesman that works for Wayman, and they obviously get them from a general contractor or the owner. And pretty much what the extent of what I get are drawings. Obviously, you have your architectural drawings and stuff of the building. And then we're usually bunched in with the mechanical drawings, which are your ductworks, your electrical, your plumbing. Fire protection is usually 1 or 2 pages of that entire set. So we're part of the mechanical set of drawings. And unlike other subsidiaries of mechanical, like the ductwork and stuff, our drawings aren't, especially for like the smaller projects, aren't that detailed. We pretty much are responsible for figuring out a lot of what we actually have to design to. A lot of times your ductwork drawings and stuff are submitted from either engineers or another company to like bid and everything like that to get the project. So they have something to start off of, what I'm saying. So when you get a duct drawing from like their salesman or something, usually they have like all the stuff they need to start with and everything. We just usually get a blank sheet of paper telling us a couple things that we have to design to, and then it's our job to figure out the rest. So a little bit of a kind of like a background is like we design like the sprinkler heads that go like in the ceilings and stuff that protects primarily what we're going after is life safety. So that means that property safety and stuff is important to us, but we're pretty much, our codes and everything are designed off of protecting life. So if like a sprinkler head goes off, it's designed to ensure the ability of people to be able to get out safely, and the fire is supposed to be extinguished before it even gets too big to become like a big safety hazard. So it's one of our primary goals. And then obviously secondary, we want to protect the building. So our objective when we get these drawings and stuff is to design a system in accordance with codes and local AHJs. Our code is typically NFPA 13 is what a sprinkler code is. And pretty much it's a pretty thick book, and we have like a bunch of different codes for different scenarios. Our code requirements all vary on the building type, what are its contents, what the environment will be, and we determine what we design to what pretty much the AHJ is going to review afterwards. So like if it's an office building, that's got a different design than say a big giant storage warehouse. So, and there's a bunch of parameters and stuff that we have to go by and before we even get to started putting like lines on paper. So it's a lot of like preliminary research and things like that. We have to go through codes and stuff, and then we can start drawing. So once we get the appropriate amount of information and resources, we then begin to design and draw. We use a program called HydroCAD, which is a sub-program of AutoCAD. So it basically got the AutoCAD look, but it's got our functions for what we need as sprinkler designers, like sprinkler head details and things like that, being able to put our piping on and things like and all of our mains and stuff like that. It's pretty much got the look of AutoCAD just with our buttons and all that stuff on it. And you'll see momentarily, I'm going to try and get something up on the screen here so we can get more of a visual representation of what I'm talking about. As of right now and recent history, we've done a lot of 2D. We pretty much are 2D drawing. So that means that we just don't dibble a lot in 3D stuff. But with the recent advancements in like programs like Revit and Navisworks, we're starting to dive into 3D as well. And I'll show you some more examples of what I'm doing in 3D in a few minutes here, because we're trying to grow in the industry just as the industry is growing towards the 3D coordination processes and things like that. And our programs are doing the same, like our HydroCAD and all that stuff. They're starting to offer more to us when it comes to 3D drawing and stuff like that. But yeah, like I said, I'll dive into that as well. That's pretty much I got for talking. Chris, I can, if it's okay, I'll screen share or get that started.
Yep, I'm gonna go ahead and try to make you a host right now.
While we're doing this, does anybody have any quick questions? You can type in the chat. I'd be more than happy to answer.
All right, Nick, you should be a host now and should be able to share.
Okay. All right. Can everyone see my screen? Yep. See a drawing with circles on it and a bunch of lines that don't make much sense.
Yeah, I can see it.
Okay. All right, cool. All right, so I'm going to start off with like more of a basic 2D plan view of what a sprinkler drawing looks like. So typically this is a basic one. This is actually the Stein-Haskell site over on Elkton Road. It was a DuPont site, now it's an FMC site. But this is a more basic addition that they put onto a building, an existing building, and we were responsible to put new sprinkler heads and everything in it. So a lot of times let me start with this. The underground for like a fire protection system is usually separate from the domestic. This is actually coming off of being that it's a Stein-Haskell site. It has its own dedicated fire loop, which means all the underground piping and stuff like that, the water and supplies and all that comes directly from a fire pump room on site. So all that water is actually for fire protection. When you get to your smaller projects and houses and commercial type deals, like in the city, a lot of times we they bring in our own fire main, but it comes right off the street level main. So we're actually sharing with domestic water, which is your plumbers and everything like that. Being that we have life safety codes and requirements for hydraulics, our piping tends to be a lot bigger than plumbing. So a lot of the smaller pipes you see above ceiling and like 1/2 inch copper and all that stuff is usually your plumbing piping. Our piping gets a little bit bigger. It starts usually at 1 inch. It goes all the way up to 6 inch. So the big piping with like the red couplings on it and everything is usually fire protection. It's pretty easy to spot if you walk into an exposed room. So this is our fire service main coming in here, and it hits our initial building riser, which is down. Sorry, it's a little slow because of the 3D. It hits our initial building riser, which is our fire service coming in there at 6 inch, and then I reduce down to 3 inch. This here is a control valve, so this will shut off the entire building's water supply for fire protection. If a sprinkler head goes off, and say initially if there's a fire, the fire department will come in here and they'll shut it off so the sprinkler head can be replaced. This is the control valve that'll shut the building off. And then of course it goes up to like a couple of gauges for pressure, and then it goes out to an actual fire department connection is when the fire truck pulls up to further help supply the system. The big pumper truck will actually connect the hose to this and pump water into the system to give us a little bit of an extra boost, or the sprinkler system a little bit of an extra boost if the fire in the case is still burning. So that's actually representing what's going on here. So that's my main building riser. And then I actually come in to a mechanical room, and the red lines are actually my service mains that go out to my branch lines that service my sprinkler heads. And then obviously the blue lines are the branch lines that actually go directly to the heads. So the water comes in here and then goes throughout the entire building. This is more of like a pretty standard building of what design terms would be. Like we're really focused on just assembly of people. There's a conference room, really basic stuff going on here. There are labs. So like you do have some chemicals and stuff being mixed in here. So sometimes the actual demand of like the fire sprinklers to be putting out so much water can be a little bit higher here. But as overall, this is a pretty standard building of what in fire protection terms. And I can turn on, this box is actually blocking my layers, but I do have ductwork on here. Let's see if I can, should I hit emit here, Chris? Or not? It says Riley Dutwin. I can't hear you, muted.
Sorry, yeah, I didn't realize I was muted. You go ahead and let him in.
Okay.
I had to, when I gave you presenter, I can't do that anymore. So.
That's fine. Yeah, okay. All right. It was just, it was in the way of my little box here, that's all.
Gotcha.
All right. Give me 1 second. Turn this on. All right, so now it looks even more of a jumbled mess, but this is actually what I did is I put in the ductwork overlay. So now what I use this for is to pretty much coordinate my sprinkler piping. As you can see, it would be just like the duct drawings you would look at. It tells me heights and everything of what the ductwork is going to be. Ductwork is usually our most common thing we coordinate to, because it's usually the most common thing we have conflicts with. So this is like part of the last step of what I do to design the sprinkler system right before I get to cut it and actually send it out to the field guys, is I would actually put this ductwork drawn in here and coordinate to that. Typically for sprinklers, we like to be the low guys ideally, but it usually never turns out that way. What I mean by low guys is closest to the ceiling. So when you poke your head up above the ceiling, sprinkler should be like the first thing you see. But then again, there's always different instances for that. But yeah, this is just one of the examples of like what I do as part of like my drawing process after the fact that I get submittals and everything into the fire marshals. But yeah, so this is a pretty good example of like what a basic job would be for me. So let me move on to another project here. Now, this here, I'm going to pop from AutoCAD over to a job, a way bigger job over at Dover Air Force Base. This is an actual aircraft hangar. I believe there's C-47s that go on this. You can see my sprinkler piping. What I'm in right now is Navisworks. So I actually already imported my piping and everything. And this job's been ongoing for about a year now. But as you can see, this is actually inside the hangar. I can give you a good reference. That's the hangar door right there that the big C-47s come in through. This is where they're going to get like maintenance and everything. Sorry, I got stuck in a wall here. So yeah, this is like a good scope of like what an entire coordination project looks like. Everything's in. So the ductwork's in, the electric's in, my fire protection is in. It's at the roof. As you can see, it's an exposed ceiling. So I'm going to be a lot up here near the structure with my sprinkler heads. And there's a lot of different things going on here. So what we usually do here, there's a lot of different types of systems. The one I just showed you just a minute ago was a wet system. So wet and dry are pretty common. That means wet meaning that there's always water in the pipe. Dry meaning that there's air in the pipe until an actual sprinkler head either breaks or discharges, and then it's filled with water. Without getting too deep into it and confusing everybody, wet's water, dry is air until a sprinkler head goes off. In here, however, it gets a little bit more complicated. This is actually a dry system and a foam system. So a lot of times with this is a government job through the Air Force. They want everything really, really done right and protected. There's some very expensive equipment on these airplanes, and they do not want water damage on them. If like they want all prevention to get unnecessary water damage on them. So what they use is they use a foam solution that actually mixes with water that is actually good for technology and high expensive equipment components and all that stuff. And it actually utilizes what they call as a foam generator, which is this big box. I don't actually have actual good detail of it in here, but this thing is like a giant, I would almost say it looks like an airplane engine, but it actually spits out this big soap bubbly stuff called foam. And literally if you go on YouTube and look at a foam system go off for an aircraft carrier, it just looks like the whole building's being filled with like Dawn dish soap. So, and it's literally going to fill the entire room with like soapy bubbles. But that's actually, believe it or not, that's actually safer than actual water discharging directly onto the plane. So I got that going on in there, and then I'll go zoom in on the riser room real quick just to show you like the extent of our 3D that we can sometimes get into. I did this whole thing. These are what they call fire pumps. So being that the foam system is so demanded hydraulically, it needs a lot of water and very quickly. So these fire pumps actually boost pressure or city pressure coming in, because that wouldn't be nearly enough. And they actually boost pressure up to like, I think these two are like 270 PSI, which is, it's a lot of pressure per square inch. And it actually puts it out of those generators within a minute's time. So it's very fast and it's a lot of pressure going very quickly. And this is actually what they call a foam tank. This is where all the foam solution sits. And what happens is the water spits through these actual fire pumps, goes back down through the risers, which I kind of showed you earlier, where they shut off the water and everything, and then actually go through the risers. You got water coming up through these pipes out the top of the risers here, and then the foam solution comes through these little lines and gets mixed in with the water at what they call a proportioner. And then that foam water mix goes out to those generators I showed you. It's a lot to take on, so I don't want to get too far into it, but it's pretty neat how like this obviously took hours of time, but it's literally going to most likely look at this when it gets installed. Like, I mean, they got it down, the details down to the last gauge and tamper switch and all that stuff. So it was pretty neat to look at when everything was finished up. Yeah, that just gives you an example of like what my end, just a sprinkler designer would actually get into. So there's a lot going on in the world today when it comes to drafting, and it's going to get pretty cool in the upcoming years as this 3D stuff gets better. But yeah, so otherwise than that, I'm not going to take up too much more time. I just kind of wanted to give a quick rundown of like kind of like what I see every day and what my job from going into leaving is like. So if you guys have any questions, I'm more than willing to answer now. I'll throw it back to you, Chris,
Okay.
for host duties.
Okay, I appreciate that.
Yep.
I do have a question, just I think for the students. What, as you're getting started, you showed a project there that obviously you've done it for a long time, and that's what you do on a daily basis. But a student that's getting started, maybe in a co-op position or right out of high school, what would their duties kind of look like?
Okay, so we actually did have a student here temporarily that started that he actually came on quick. So pretty much we start them with smaller projects. Like a lot of this stuff, obviously these buildings that we do and everything, probably about 75% of our work is in an existing building. So people coming right in usually the existing buildings and stuff, they what they call like tenant relocates and things like that. So what happens is we would take an existing sprinkler head and we would just move it to another location. So like if the ceiling grid like moves at all and stuff like that, they usually want to see that sprinkler head in the center of the actual acoustical ceiling tile. So they would literally just move heads around to be centered up, but also keep the spacing within code, NFPA code, which is typically pretty simple. It could be like a 14 foot by 14 foot radius or something like that, and just lay out different sprinkler head drawings in jobs that are like no more than 20 sprinkler heads. So like that actually is what I started doing, and it was actually, you learn a lot more through the little things like that. That really gets you going into like getting comfortable with the bigger stuff, like the newer stuff and things like that. So yeah, it's typically just a lot of laying out spacing the sprinkler heads and things like that, because that's where it all starts. So it's kind of baby steps from there.
All right, students, what other questions? Our instructors, what other questions do we have for Nick while we have him?
I got a question.
Go ahead.
So, like, how would the process be different in a residential home rather than like a commercial one?
That's a great question. Residential actually has their own code. Now, residential is depending on state too. A lot of things in the state govern on what residential stuff that they use. Now, there are residential codes in NFPA 13 called 13R and 13D. And as you can see, like a lot of residential places and things like that, they don't really have dedicated fire service mains or anything like that. So in many instances, we have to put like an actual tank of water in their basement or somewhere along like inside the house to be able to properly supply a sprinkler head for a given amount of time. And codes can get very different in residential occupancies depending on like how big the house is and whether even like it applies to like hotels and residential and nursing homes too. So a lot does change. Piping can change, sprinkler head spacing can change. It's a different world. It actually is kind of interesting to get into like residential too, because it's kind of a change up from commercial. And that's one of the nice things about this business is you can kind of change things up every once in a while if you want to, and try to experience different types of buildings and things like that. But yeah, that was a great question. As far as Delaware goes, I think so far anything over 10,000 square feet requires a sprinkler system. Any house, any hotel, any restaurant, anything like that. That's a pretty common code. And I think Pennsylvania or Maryland's actually adapting any new construction of houses and stuff needs sprinkler protection now. So that's actually coming very quickly.
I think they've made changes even in basements now over a certain square footage. You sprinkler or fire protection of other some. It's one of the options now that you can go to in Delaware.
Yes, and actually insurance actually gives you a good kickback for putting sprinklers in your household as well.
I have a question. What building codes do you need to follow when designing a sprinkler system?
That's also a good question. So I brought up NFPA as one of our go-tos. That's a National Fire Protection Agency. A lot of AHJs and jurisdictions adapt that as their primary fire protection code. But there are times where, especially in government worlds, where we go to either the IBC, International Building Code, the International Fire Code is another one. I'm drawing a blank on the government one I'm doing with Dover Air Force Base right now, but I just had that paper in front of me too. But there are other ones that they directly kind of guide you to saying, okay, here's what we abide by. We don't want, and government's very serious. They are very, very stringent with their code. Like they notice very small details in it and things like that. So you got to kind of get a handle on that before you even start the project. That was primarily one of my talking points on like gathering your resources and doing your research before even drawing a line on paper, and kind of getting comfortable with the building you're designing to. So, but yeah, it's a good question.
Who else has questions for us? Nick, what would you say about communication?
I got another question.
Go ahead.
I'm sorry, I didn't know if you were talking. I can't hear anything.
No, go ahead, Damon.
It might be like really specific and you might not know it off the top of your head, but like this whole school has like sprinkler systems in the hallways and stuff, but don't have them like in the room. Is there a reason for that?
It's a good question. Let me think about that for a minute. Now, okay, so it could have been something that was done through a renovation at some point, and they just haven't gotten to the rooms yet. So a lot of times in like hospitals and schools that haven't adapted to the newer, like they're grandfathered in. So pretty much like when something happens, like if there's like you get new ceilings or like there's a renovation or new hallway or something that's put in, the fire marshal will walk in and say, okay, you got everything opened up. I want sprinklers in here now. It happens a lot in hospitals too. So they eventually that a lot of times a school will be piecemealed into having a full sprinkler system, but they're not going to usually have a time frame to shut down the whole school unless it's like a big renovation to be able to put a sprinkler system in it. So it usually bridges with other types of projects that are done, such as ceiling renovations, wall layout, new wall layouts, all that stuff. And it could be something else code wise, but I can't think of anything off the top of my head. Maybe common area code or something like that, but I think it was probably from a renovation.
I've got one more. Can you just talk about communication skills as far as written versus verbal, having to talk to other trades or having to talk to your foreman out in the field, just how important communication is in what you do every day?
Yeah, communication is key. You got to have everybody on the same page. There's jobs where there's not a lot of lack of communication and they usually don't go well. I experience it every day. There are jobs with great communication that go very well. It's something that as long as you're honest with people and you reach out to them, let them know. I call my fitters every once in a while just to see how they're doing. I want to know like things that I could get better at and see their eyes through things because everybody's got a different view on things because they're doing a different portion of the industry. So I want to try and like I'm never going to be like have everything right on square with a fitter the way he sees things, but I want to understand if I could do something better that makes his life easier in the future. If I did something wrong on one project, I want to see what he thinks what I could do better. And I no matter how good I get, I always reach out to them. And as far as communicating with the customers and the building owner and the GC, to keep everybody on the same page, it's key to like kind of like fill them in on what you got going on. If there's a concern, there's a way of doing things. There's always a procedure. A lot of times it's either through an RFI which is a request for information, or even sending an email and getting a paper trail. But communication is always key, because if you don't communicate, things can go south really quick. And like I said, I've seen entire jobs that have good communication and bad communication, and they're usually on way separate ends of the spectrum. So yeah, that's a good talking point there.
All right, ladies, anybody else have questions? Or we let Nick go back to work?
Nah, I'd rather just stay and talk all day.
I got a question for you. Statistically, I don't know if you have any statistics on this, how much money has been saved due to fire protection with sprinkler heads? How much has it saved, I guess, homeowners or insurance companies in cost to have these systems in place because of how quickly it prevents a fire from spreading throughout the house? Like, is there a statistic on that?
Oh, wow, I wish I had Alicia in here for that one. That's usually her ball game. So I know that I could just I don't have a number for you, unfortunately. I don't want to spit out any wrong information, but so a sprinkler system, I could just tell you from personal experience, just from hearing things and reading reports and stuff, because we're always directly involved in the industry. So I have emails and everything that come through from different fire protection nationwide agencies and things like that. They always send emails about like sprinkler head saves entire apartment complex, or sprinkler head discharging actually saved an entire building. And obviously you're going to have the water damage aspect of it, which is like something somebody always ends up bringing up. But then again, you're going to be saving lives a lot of times, because that's what we're supposed to be doing, is we're focused on life safety here. So obviously we care about the building and its contents. That's a big part of our industry, but pretty much getting everybody out of the building safely is a very big thing for us. And sprinkler heads are designed to pretty much put out a fire before it even gets to the point where it's too big to control. And a lot of times fire departments and stuff, before they even roll up, and the sprinkler, they vouch for it all the time. When there's a sprinkler system in there, they know it, because the fire's pretty much gone, before they even get there. But then again, if there's no sprinkler system, then you've got a pretty big fire on your hands. So yeah, they do their thing, and you'll hear around the industry, you'll hear a varying type of opinions on whether people like them or not. But just working in the field and stuff like that, I've come to learn that they do their job if designed properly. And they have saved millions of dollars, at least millions of dollars.
All right, anybody else? All right, I just want to say thanks, Nick, for taking some time today to come talk to. We've got students on here from 4 different schools. We've got instructors all up and down the state. So I really appreciate you sharing your wisdom and taking some time and kind of just letting our students know what else is out there. It's not always everything that they think it is. And this is an opportunity and a career path for them to, if they're interested in fire protection, to kind of look into it further. So I really appreciate it. Thank you.
Yeah, if anybody has any other questions for me after the fact or anything, feel free to reach out to Alicia or myself. Obviously, you know where I work. You can get my email and just shoot me anything. I'm more than willing to answer any other questions at any time.
Perfect.
I'm happy to be talking on this. So,
well, again, thank you. And everybody have a good day.
Thanks a lot, guys.
Thank
Thank
you.
you.